In this video, we're going to be solving other equations. All right, notice that in this equation we have a fourth degree function. It's not quadratic, it's fourth degree. All right, we don't have a constant, so without a constant we can look for a common factor, and that common factor looks to be 4x squared. When you divide out a 4x squared, we're left with x squared, and here it looks like we're left with 4. Right, by inspection we can see that this can factor down some more. So we'll keep the 4x squared, and we'll break this up into two parentheses. It's going to break down into a sum and difference of like terms. So it looks like x plus 2 and x minus 2. It looks like we've done all we can, so now that we have factored it completely, we can set each factor equal to 0 and solve. Since we have three factors that multiply and give us 0, we're going to have two vertical bars here to organize our work. Divide by 4, so x squared is 0. You can extract the roots if you want, but you're going to end up with just x equals 0 there. X equals negative 2. And x equals 2. I've checked them all, they all work. One at a time you can replace them back into the original equation. Right, I'm going to move across here. Alright, we have three terms. We have a trinomial. First, look for a GCF. We can divide out a 5 from all the coefficients, and we can also divide out an x from all the terms. So it looks like 5x is our GCF. Okay, factoring that out leaves x squared. You can check by multiplying back in to see that you get the original term. Dividing 5x out of 30x squared leaves 6x, and dividing 5x out of 45x leaves 9. We want to look at what we have left here, this factor. It looks like it's going to factor some more. And thinking about our previous work with quadratic equations, which that's what this is, and a being 1, we don't have to factor by grouping. I think it's going to be just as easy to go to a binomial times a binomial. Alright, we can see that this is going to factor. If it for some reason didn't factor, we can always use quadratic formula on that trinomial. But it's going to factor into x here, and a plus 3 and a plus 3. So this is a binomial square. We're completely factored. We're going to set each factor equal to 0 and solve. You can real quickly check by plugging 0 into the original problem for every x that would result in a 0. You could check negative 3 and it also would satisfy the original equation, resulting in the computations giving us a 0. And same thing with this remaining factor. Alright, well this remaining factor actually doesn't need to be repeated since I already had it here. Alright, let's take a look at example 3. So we have a fourth degree function. Alright, in that case, what you might want to identify is that with this exponent of being 4, half of 4 is 2, and the exponent here on this term is 2. Okay, this is actually going to factor right away into a binomial times a binomial. It's not going to be too bad since a is 1. We know that this is going to have to be x squared, and so with this first term to produce x to the fourth, we're looking for factors of 3 that add to negative 4. So that's going to be a minus 3 and a minus 1. I can't factor this. I mean, I could into square roots if I wanted to, but it might be just as easy to set this factor equal to 0, add a 3, and extract the roots instead of trying to factor it. But I'm going to go ahead and write it down again, because what I see is over here, this is a difference of 2 squares. I'm subtracting 2 terms that are perfect squares. So I'm going to take this last binomial and break it into x minus 1 and x plus 1. We'll separate at the factors. This is the interesting one right here. But notice you don't have a linear term, so you can solve it by extracting the square roots. So add a 3. We're going to bring in our square root. It's an even root, even power, so we bring out the absolute value, bring down the square root of 3. Remove the absolute value, we have 2 solutions, the positive and negative root 3. Okay. X equals 1 here. This should produce x equals negative 1. So for this equation, we have 4 solutions. We can have at most 4 solutions because the highest exponent is 4. Here we had 3 solutions. That's the most we can have. You don't have to have that many, but we happen to have 3 here. Look at the original or the first equation. It was a 4th degree equations, and we could have at most 4 solutions. It just happened to only have 3. That's okay. It could have 4, 3, 2, 1, or 0 solutions. All right, let's take a look at example 4. Okay, this 4th degree equation can have at most 4 solutions. You can have 4, 3, 2, 1, or 0 solutions. I see that the highest exponent is 4. The next highest exponent is 2, and 2 is half of 4. So it looks to me like it's going to be able to be factored into an x squared here and an x squared here. It is a perfect trinomial, I guess, so this would be plus 1, and this would be plus 1. I can't factor a sum of 2 squares, only a difference of 2 squares. Okay, so my only other option is to set the factor equal to 0. Subtract a 1 on both sides. And if at this point you see when you bring in the square root, you're going to have the square root of a negative number. At that point, if you see that that's no solution, it's perfect. Just put no solution, you're done. Since this is a repeated factor, the same results are going to occur, so we're just done. There are no real solutions. Okay, we're going to change it up a little bit. Notice in this equation we have a square, a radical, square root. The technique for solving these types of problems is to isolate the square root and then square both sides. So I'm going to add a 10. I need to continue isolating, so I'm going to divide both sides by 3. So square root of x equals 10 thirds. All right, I'm going to rewrite the problem, and then I'm going to show that I'm going to square both sides. I need to get rid of that radical. So, oh, that should have been a square. Squaring a square root results in us just having x. If you square and not square root, you don't need the absolute value. So look at the difference between example 5 and how I squared a square root as opposed to I started with the square and I square rooted it. Absolute value is necessary here, but squaring the square root just results in what's underneath the radical, or just x, no absolute value. And this is going to be 100. 10 squared is 100, and square the bottom, and that's 9. So other types of equations. All right, let's deal with the cube root. I don't know why that's so far away. Same technique when you're solving radical equations. Isolate the radical and take it to the appropriate power. subtract an 8, get negative 8. I'm going to write down the problem again because I'm going to cube both sides. Let's undo the cube root by cubing both sides. Alright, that's not going to undo the radical. We're going to get 2x plus 1. Oh dear, negative 8 cubed. Well, I know that's going to be negative. I'm going to come over here. 8 squared is 64 times another 8. 32, 3, 48, 512. Solve the resulting equation. It's linear, so let's subtract 1. So that becomes negative 513. And let's divide by 2. So the result is negative 5/13 divided by 2. Because this number is odd integer, we can't simplify it any further. Alright, a little bit more work to do with solving other types of equations. Alright, we're back to a radical, a square root. So again, the technique is to isolate the radical. So we're going to need to subtract a 4. Okay, and then we're going to square both sides, so I'll rewrite the problem. Alright, the result is 5x minus 26. Notice that over here, you're going to have to FOIL this. When you square this side of the equation, you can't square just x by itself and negative 4 by itself. You've got to take the entire side of the equation, whether it's 2 terms, 3 terms, 4 terms, and raise it to the appropriate power. So let's FOIL this. So if you were to expand and write out 2 of these side by side and multiply them, the result would be x squared minus 4x minus another 4x, or minus 8x plus 16. Now what we're going to have to do is we're going to have to solve this resulting equation. Well, I noticed that the highest power is a square, so it's quadratic. So I want to think about the techniques that I did in my previous work. Well, I only have this x squared term, and it has a positive 1 coefficient, so if I moved it over here, it'd become negative, and I don't want to work with negative, so I'll just leave it here. Looks like I'm going to bring these two terms over here, solve it for 0, and try and factor. If factoring doesn't look like it works, then I might want to, think about completing the square or quadratic formula. Alright, so let's zero this side out. So we have x squared over here, but when you subtract a 5x and collect it with negative 8x, that becomes negative 13x. And when I add a 26 to 16, I'm going to get 42. And I like the 0 on the left side of the equation, so I'm just going to trade sides. A quick inspection to see if this would factor would be to think about multiplying a times c. If I get 42, do I have factors of 42 that add to negative 13? Because if I can't find a set of factors that multiply and give me 42 and add to negative 13, then that tells us it doesn't factor, and I'm going to have to use quadratic formula. Okay, so it looks like it's going to be 1 in 42, 2 goes in there 21 times, 3 isn't very obvious, but it does go in there 14 times. 4 isn't a factor of 42, neither is 5, but 6 and 7 are factors, and that completes the possibility of factors. Well, if the 6 and the 7 are both negative, the product is positive, but the sum is negative 13. So it will factor. You don't have to do grouping, because the coefficient is 1, which means this is x and this is x, and I found my constants. We're solving, so set each factor equal to 0 and solve. Alright, this is one where it's real important to check your solutions. This is one, meaning one equation that has a radical in it. That's usually where some of your solutions won't check. So anytime you solve a radical equation, you should check your proposed solutions. So we'll do that here, and I think I actually need to go back and check it on some previous problems too. But let me check these first, and then I'll go back and look at my work, because maybe I should have checked and I need to make an adjustment. All right, let's plug 6 in. So 5 times 6 is 30. 30 minus 26 is 4. So square root of 4 is 2. 2 plus 4 is equal to 6, and that x had to be replaced with that 6. So this checks. This is good. Let's check 7. So 7 goes in here and here. So let's see. 5 times 7 is 35. Minus 26. 35 minus 26 is 9. Square root of 9 is 3. 3 plus 4 is 7. This one checks too. Right, and as mentioned earlier, I think we dealt with some equations up here that we probably need to check because these are radicals. Let's look at this one right here. When I plug in negative 5/13 over 2, the 2's will cancel, and I'm left with negative 5/13 plus 1, which is negative 5/12. I can cube root a negative number, and that's actually going to be negative 8, and negative 8 plus 8 does give 0. So this one does check. Okay, this one right here, if I were to plug in this solution and square root it, I'd get 10 over 3, and the 3's would cancel, and I'd have 10 minus 10, which is 0. So, yep, those did check. All right, let's look at one more example in this video. I think we can fit it in. All right, I think I'll put it right over here. Oh, just a second, let me fix that. Yeah, I didn't want that there. I wanted x plus 1, yeah. Alright, so paying attention to what we have here, we actually have two radicals, one on each side of the equation, so that's great. What we're going to do is we're going to square both sides. So let me rewrite the equation first before I do that. And I know I wrote a 1 there, it's just I think my pen's getting tired. Okay, squaring results in x plus 1. Don't need the absolute value. That's what, just when you bring in the square root. And this is going to be 3x plus 1. The 1's will cancel, so I'll have x equals 3x. In that case, I can't divide out an x, but what I can do is I can solve for 0. So I'm going to actually bring over the x here and make this 2x. I'll trade sides. Divide by 2, I get 0. Let's go back up to the beginning and check that. If x is 0 here, we get the square root of 1. If x is 0 here, the square root of 1. So that is a good solution. So this was solving other types of equations. We did have to refer back to and use our previous skills as well, but maybe the way we started with the problem was different than when we were solving quadratic equations.